Hello everyone, welcome back to the channel. In today's lecture, we are going to learn BLDC type systems. This unit is extremely scoring and understanding. BLDC drives will also help you in interviews, EV industry jobs, and practical applications. So let us begin. The heart of electric vehicle, right? BLDC motors are the heart of an electric vehicle. Unlike traditional motors that use brushes and a mechanical commutator, BLDC motors use electronic commutation. Because of this, they become more efficient, more reliable, more long-lasting. They convert electrical energy into mechanical motion with high precision, which is exactly what modern EVs need. Smooth acceleration, high torque, and good efficiency. Now let us look at the construction of BLDC motor. There are four main parts. One is stator, rotor, Hall sensors, and power converter. Stator contains three-phase windings. When energized, these windings create a rotating magnetic field. Rotor, it has a high-strength permanent magnet. These magnets don't require any external excitation. Hall sensors, these sense the position of the rotor. The controller uses this information to know which winding to energize next. And the power converter, this is the electronic controller which switches MOSFETs or IGBTs and performs electronic commutation. This construction allows BLDC motors to run efficiently and reliably without brushes. Now let us understand how BLDC works. BLDC works in motoring mode. First step is rotor position detection. All sensors detect the rotor position. The second step shows electronic commutation. Based on rotor position, the controller energizes the correct stator winding. Step 3, rotating magnetic field. The stator creates a rotating magnetic field, and the last step is the rotor follows this field and produces torque. This cycle repeats continuously, giving smooth and efficient rotation. Coming to the next slide. When the driver, now let us understand how regenerative braking works. BLDC motor BLDC motor support regenerative braking, which is extremely important in electric vehicles. When the driver leaves the accelerator or presses the brake, the motor behaves like a generator. The spinning rotor induces voltage in the stator. Current flows back through the converter into the battery. This charges the battery while slowing down the vehicle. So with regenerative braking, we get extra driving range, reduced brake wear, improved efficiency. This is why EV manufacturers prefer BLDC motors. Now let us look at the performance characteristics of BLDC motors. So how the speed and torque characteristics work. So in BLDC motors, high starting torque, there is a high starting torque which shows perfect for EVs because vehicles need high torque and low speeds. There is also constant torque region. Here the BLDC motors maintain almost constant torque over a wide speed range. Then there is an extended speed capability. They can run at higher speeds without complex gear systems. Efficiency. Their efficiency peaks near common driving speeds, improving battery performance. So overall BLDC motors deliver excellent torque and efficiency across the entire speed range. Now let us understand What is a closed loop control with PI controller? To control the BLDC motor accurately, we use closed loop control. Why? Because open loop systems cannot handle load changes, temperature variations, or battery voltage drop. The PI controller ensures stable speed, quick response, zero steady state error. Here's we will see how it works. Driver gives a speed reference. This motor speed is measured. The error is calculated. PI controller processes this error. Controller adjusts the inverter input. So this gives consistent and smooth control essential for electric vehicles. Now we will understand the PI controller. This PI controller has two components, right? So the proportional term. This reacts immediately to speed error. If the motor is slower than required, the P term increases voltage fast. The integral term removes the remaining error over time. Even if the motor stabilizes slightly below reference speed, the I term slowly corrects it. So together they give fast, accurate and stable speed operation. So the next slide shows advanced vector control. That is, we can also call this as advanced control, vector control or field oriented control. This method makes a BLDC motor behave like a separately excited DC motor by controlling flux ID and torque IQ. Vector control transforms the three-phase currents into two orthogonal components. ID controls flux and IQ controls torque. So two separate PI controllers regulate these components. The result is high efficiency, extremely smooth control, instant torque response, perfect performance for EV acceleration and hill climbing. This is the same technique used in modern EV powertrains. Now let's come back to what is regenerative braking. Capturing energy, extending range. So what does it mean? Regenerative braking has a huge impact on EV performance. This study shows up to 15% increase in driving range, up to 70% reduction in brake wear, around 20% improvement in overall efficiency. So every time you slow down, the EV is actually recharging itself. This is one of the biggest advantage of BLDC based drive systems. Now let us discuss where BLDC motors are used in EVs. So now let us first understand why BLDC motors for electric vehicles. Because they have exceptionally well efficiencies around 85 to 96%, right? This reduces energy consumption and extends battery life. It has higher power density, compact size, delivers maximum power output per unit volume. There are no brushes to wear out, enabling maintenance free operation for years. They have precise speed and torque management, which enables smooth responsive driving. So these are the few key applications like electric cars, like traction motors for passengers vehicles from compact cars to luxury sedans. E-bikes and scooters have lightweight, efficient drives for personal mobility solutions. There are electric trucks where they have high torque motors for commercial and heavy duty applications. They are also used in hybrid vehicles where secondary motors in hybrid electric vehicle contributions configurations, right? So now let us move towards what are the real world impact of this. So there are some real world statistics. So 90% system efficiency can be achieved under optimal conditions. BLDC motors are capturing nearly 40% of the EV motor market, up to 50% energy savings compared to brushed DC motors, zero tailpipe emissions, much lower operating and maintenance cost. All these factors make BLDC motor drives a dominant technology in EVs. Now let us understand what are the environmental and economic benefits. Environmentally, we can see that there are no emissions, then less noise, lower energy consumption, better urban air quality, right? And what about economical? In economical, we can see there are no oil changes, no brush replacement, lower electricity cost than petrol, longer motor lifespan. So here we can see, so EVs with BLDC motors are cheaper to run and better for the environment. So to conclude, I will say that BLDC provides unmatched efficiency, precision control, smooth acceleration, energy recovery, and long-term reliability. So as EV penetration increases, BLDC motors will continue lead due to advancements in power electronics and magnetic materials. So the future of transportation heavily depends upon BLDC drive systems. Thank you for watching. I hope this video helps you clearly understand BLDC drive systems. If found helpful, please like, share and subscribe to the channel. See you in the next lecture.